Hello friends, this is lecture number 5 on Staad Pro software. In last lecture we see the use of different modeling and editing tools from the toolbar box and ended our session in between with load definition. Today, before defining load definition, let's discuss about in brief loads can be broadly classified in dead load and live load. In dead load, self weight of material, that is weight of beam and column, which is generally 24 kN per meter cube for simple concrete and 25 kN per meter cube for RCC concrete, which is given in IS 456 code and IS 875 code also. Then the flow load, it is generally slab have 150 to 200 mm thickness. So here we take 150 mm thickness of slab. For that we need 3.75 kN per meter square load acting per unit area of slab. Then the third one is wall loaded, which can be converted in UDL. Generally a single brick masonry is 120 mm thick with plastering and finishing, while double brick have 240 mm thickness, that is for 3 meter headroom and 120 mm thick wall. We have 7.2 kN per meter UDL as unit weight of brick is 20 kN per meter cube. Similarly, for imposed load, we can take this load from IS 875 part 1, part and part 2. For live load, it is considered as imposed load, which is 2 to 3 kN per meter square for residential building. Okay, now define load definition. Firstly, we define this load, then make their combination to analyze its effects on structure. Define combination. Firstly, primary load, add dead load, then live load, close the tab. Define dead load, self weight, UDL, as discussed before, 7.2 kN per meter for single brick wall. Edit, similarly 14.4 kN per meter for double brick wall for 240 mm wall thickness. Now flow loading. Flow loading can be defined by defining a three-dimensional zone that completely envelop the member to be loaded. that is by defining y range, x range and z range. By clicking nodes we get its coordinate, that is 0 0 0. Similarly maximum, that is 12. Put some higher values so to eliminate any error. So we take 12.2 meter. Dead load floor pressure, that is minus 3.75 kilonewton meter per meter square. We had discussed earlier. Click add, close the tab. Here we can also apply one-way distribution and select the member. You can see if we initially apply the floor load, we have difficulty to apply the other loads because members are not seen clearly. So right now delete it. At the end we will apply it. Assign self head, assign dead load. Assign wall load. For interior panels, we select all the interior panels in one go. Now assign to selected beam. Click assign button. Click yes. Similarly for outer wall, we have to put negative, goes vertically downward. Now for outer wall, we have to select the individual section. Now here the right arrow shows the member on which the load is applied, while the bulb column shows the member which are being selected on the screen. Now see the selected member has right click. If we remove the right click from the right column, the property is deassigned. Now the live load definition. At floor load is -3 kN per meter square. The range is same 0 to 12.2. Click add the floor load. Similarly for dead load. Now here we can see the selected load appears in blue while others are in same definition display in green color. Now here we can see the selected load appears in blue while others in same definition displayed in green color. Now define combination. Click add button to edit. Close. Rename it. Now perform analysis. Then run analysis. One error is there. Density not provided. The similar error comes before also. Just refresh material property. Similarly for reference to run analysis. Save it. Error resolved. Warning can be ignored. Go to post processing mode. By clicking levels. Here we have quick access keys. use these shortcuts with Ctrl plus Shift. Support reaction. Here we can't see the support reaction from any view. So select all node, go to report in tool menu and select support reaction. We get it in separate table. Maximum load 1414.729 kN in y direction. While other have negligible shear force. Here we can change our post-processing result by changing the input data. Click the result tab, select load cases and click OK. Beam shear force bending moment diagram. Animate it, scale it, click apply. Take pictures, name it, click OK to save it. Similarly for now the report, generate report, select the needed quantities, select pictures, click OK. Now our report is generated. Here we can see number of pages of our report. Beam combined axial and bending stresses table. Eliminate some unwanted details. Click next page, next page. Here we have beam and force summary. Similarly, the reaction summary. Here we finish our lecture 5. In next lecture, we will see the use of structure wizard and menu bar tool. Thank you.